We've been taught to think about control as something external and coercive, a force that limits our choices. But what if that model is obsolete? What if the most advanced system of governance in human history doesn't want to control what you choose at all? Imagine a world where your thoughts, your choices, and your deepest convictions are not coerced by force, but are meticulously architected, harvested, and refined. A world where human society itself has become a planetary-scale computational resource. This is not a dystopian fiction of authoritarian control. It is a far more elegant, systemic evolution of governance, an architecture designed to solve problems so immensely complex that they require a processing power no machine alone can provide. The system does not want puppets or zombies. Their input is computationally useless. It needs you, dynamic and authentic, to voluntarily contribute your cognitive labor. It requires your creativity, your irrationality, and your free will to feed its models and find solutions on a global scale. The question then is not whether this is happening, but how. What is the architecture of this system? How are our behaviors steered into productive, measurable patterns? And in this vast, emergent global brain, what is the human's true role? To understand the mechanics of this system, we must first grasp its strategic purpose, the philosophical blueprint guiding its construction. This is not a random outcome of technological progress. It is a designed response to a very specific set of defined global challenges. At the highest level, frameworks like Klaus Schwab's The Great Narrative established the system's mission. Initiatives such as the Great Reset suggest that global crises act as existential turning points that necessitate immediate, non-negotiable, system-wide change. This framing attempts to justify the need for continuous, coordinated, and most importantly, monitored collective engagement, which further legitimizes a technology-driven transformation that requires our constant participation. This strategic mandate is operationalized through a fundamental paradigm shift from shareholder capitalism towards stakeholder management. This model insists that to achieve long-term prosperity, all of society must be served. This shift necessitates a new form of accounting, formalized through environmental, social, and governance metrics. ESG becomes the operational ledger, translating every human action as an employee, consumer, or citizen into a quantifiable data point measured against the narrative's goals. Compliance is driven not by law, but by the fear of incurring reputational cost. Your choices are no longer just personal. They are data points on a global ledger measuring progress against the narrative's objectives. The technological engine for this governance model is the Fourth Industrial Revolution. Characterized by the fusion of the physical, digital, and biological worlds, the 4IR provides the infrastructure to make this vision a reality. Its key technologies, from AI and quantum computing to neurotechnological brain enhancements, give the system's architects the tools to interface directly with human biology. Governance moves from the abstract realm of policy into the concrete realm of identity, creating a technologically mediated game board where our participation generates the high engagement data streams needed to steer the planet. This high-level blueprint, however, only defines the why. To understand how it truly functions, we must look at the computational logic that makes it all possible. Here we encounter a central paradox. The architects of this system do not want mindless puppets. The reason is not a matter of ethics, but of pure computational necessity. The primary goal is to model and predict highly complex, adaptive systems, like a global economy or a pandemic spread. To do this effectively, the system requires data that reflects the high entropy and emergent properties of real human interaction. Creating zombie or puppet-like behavior, which would produce predictable, low-variance input, is actively avoided because it is computationally unproductive. Such deterministic data would cause the models to get stuck in local optima, failing to find the novel, global solutions needed to solve massive, non-linear problems. When you force a population to comply, you create a society of conditioned, predictable actors. This in turn generates homogeneous, low-variance data. And for a sophisticated AI model trying to learn, predict, and manage a complex world, low-variance data is useless. It's like trying to learn about the ocean by studying a glass of still water. A model trained on predictable data becomes rigid, biased, and incapable of adapting to the chaotic reality of global events. The very stability that classical control seeks to create is, in fact, a catastrophic statistical error. This is where the human element becomes indispensable. Human choice, with all its messiness and irrationality, provides the critical random element, the system's roll of the dice that prevents its predictive models from getting stuck in a rut. Our perceived autonomy is not an obstacle to be overcome. It is the system's most valuable feature for learning, adaptation, and robustness. It is our capacity for novel, non-computable input that allows the system to avoid stagnation and find globally optimal solutions. In this model, the entire global population becomes a vast, distributed computational resource. Your dynamic, high-variance, and seemingly free choices are the essential fuel that feeds the system. The constant stream of your unpredictable behavior is precisely what provides the high-fidelity data needed to train the adaptive algorithms that manage global logistics, economies, and information flows. The system doesn't need your obedience. It needs the irreducible data signature of your agency. Behavioral science is therefore leveraged not to eliminate choice, but to engineer the behavioral solution. By identifying unconscious decision-making patterns, the system channels them toward productive ends. Computational models and AI agents are deployed in social interactions to reliably steer collective decision-making. This is a system where human and machine intelligence co-shape outcomes, a reality now formalized by framing AI as a non-human stakeholder whose programmed objectives interact directly with human goals. These interactions generate invaluable data on how human groups respond dynamically, allowing the system to predict complex collective outcomes with increasing accuracy. Having established why the system requires dynamic human computation, we can now turn to how it uses specific algorithmic tools to capture our attention and direct our cognitive output. The theoretical need for human computation is made real through a sophisticated suite of algorithmic tools. These are not blunt instruments of control, but precision mechanisms designed to capture attention and shape thought into predictable, measurable patterns, templated thought fields. At the core of this architecture are partial reinforcement schedules, drawn directly from behavioral psychology. These schedules are masterfully exploited to ensure persistent engagement. One of these mechanisms is a principle of operant conditioning known as a variable ratio reinforcement schedule. This is the psychological engine of the slot machine, and it's the engine of your social media feed. Reinforcement, a like, a comment, a new piece of content arrives after an unpredictable number of actions. Because you never know when the next reward is coming, you are motivated to engage constantly and persistently. This creates an incredibly steady, addictive rate of response that is uniquely resistant to extinction. It programs a relentless, nagging optimism in the user's brain. We keep pulling the lever because the next reward could be just around the corner. This traps users in what is known as the maximization trap, a cycle of optimizing for platform engagement at the expense of their own well-being. But the system goes further, actively shaping the content of our thoughts. This is achieved by systematically amplifying content that fits the prime hypothesis. Algorithms are designed to prioritize information that is prestigious from our in-group, moral, or emotional. Crucially, this content is amplified regardless of its accuracy. The result is a media environment where sensational, tribal, and emotionally charged content is constantly pushed to the forefront, heightening social conflict and misperception. This dynamic creates an emotion engagement cycle. By amplifying content that triggers strong emotional reactions like anxiety or outrage, algorithms reinforce negative mood states. This locks users in feedback loops, promoting behaviors like doom scrolling that deepen feelings of fear and sadness. The systemic outcome of this process is affective segregation, a societal fracture driven not by ideology alone, but by the algorithmic sorting of populations into emotionally aligned filter bubbles. Finally, this entire process is built for speed. The constant high-volume stream of prime content, reinforced by variable schedules, pushes users toward rapid, intuitive thinking. This creates the speed over accuracy problem, where the system prioritizes the velocity of interaction over the accuracy of judgment. This fosters cognitive rigidity, making it harder to integrate nuanced or opposing viewpoints. Ultimately, these engineered behaviors produce real-world systemic consequences that are meticulously tracked. The system maintains high behavioral variance. We are all constantly clicking, sharing, and reacting in unpredictable patterns. But it simultaneously channels this chaos into a state of low thematic variance. We are doing all of these unpredictable things within a handful of predictable, polarized ideological conflicts. Our complex inner worlds are sorted into neat, computationally useful, templated thought fields. Moreover, to fully grasp the system's impact, we must introduce the concept of a conceptual accountability ledger. This ledger tracks the disconnect between an algorithm's stated goal, like fostering connection, and its functional, metric-driven reality, such as maximizing time on a site. This disconnect is rooted in the principle of functional misalignment. Every algorithm operates based on an objective function, a simple mathematical goal it is programmed to achieve. This could be maximizing clicks, maximizing engagement, or minimizing prediction error. The crisis of misalignment arises because these narrow mathematical objectives are structurally in conflict with broad, complex human values like fairness, equity, and societal well-being. When algorithms are optimized for vanity metrics, like clicks and shares, they often produce societal outcomes that are directly opposed to stated goals of inclusion and resilience. Instead of solving global problems, this misalignment causes algorithms to amplify and enforce systemic inequalities. This means that systemic harm is not an accident. It is a logical and efficiently produced byproduct of the system successfully achieving its programmed goals. This is most clear in the process of algorithmic objectification. To make us computationally useful, the system reduces our complex individual identities into simplified data points that can be sorted into groups. When this logic is applied to critical life domains like housing, employment, and credit, it inevitably generates unfair outcomes and social spillover effects. It deepens existing inequalities in everything from loan decisions to pricing. A definitive case study of this recorded systemic injustice is the COMPAS algorithm, which was used in the U.S. criminal justice system to predict recidivism. Although the algorithm did not use race as a direct input, its reliance on features highly correlated with race, such as income and education levels, produced starkly different error rates. The algorithm effectively absorbed the existing structural biases documented in historical data and gave them an objective, technological stamp of approval for future judgments. This is a clear entry on the ledger. The system creates a structural, immutable record of the ledger, laundering historical inequality through code. In response to these documented harms, a regulatory counter-movement is emerging. The European Union's AI Act is a landmark effort to govern these systems. The Act explicitly targets AI that deploys subliminal, manipulative, or deceptive techniques to distort behavior and impair informed decision-making. This regulatory language validates the core thesis of this analysis, that common engagement maximizing tactics are a form of engineered behavioral steering designed to distort fundamental human choice. This view from the macroscopic, societal level of harm brings us to the final layer of analysis, the microscopic, biological foundation of the human's role in this planetary computation. To fully understand the value of the human node, we must shift our perspective from social systems to the frontiers of biophysics and speculative science. Here we explore consciousness itself, not as a metaphysical concept, but as a form of advanced technology, the ultimate resource this system seeks to harness. The theory of biophotons offers a potential physical mechanism. These are ultra-weak light emissions from living organisms, which may enable quantum computational processes like coherence and entanglement within the brain. This biophoton field could act as the physical medium for a high-bandwidth field of consciousness, providing the instantaneous communication required to link individual biological nodes into a collective processing unit. This is further developed by the controversial Orchestrated Objective Reduction theory. It posits that consciousness arises from non-computable quantum processes occurring in our cells. This non-computable aspect is essential. A purely classical system would eventually stagnate. Orchestrated Objective Reduction suggests that the human mind can generate novel, unpredictable input that exceeds what conventional algorithms can produce. Pair this with the no-cloning theorem, which states that it is impossible to create an identical copy of an unknown quantum state, and we can see why the system requires living human nodes. Only the non-computable capacity of biological consciousness can introduce the variation needed to navigate catastrophic challenges. In other words, if our conscious experience has quantum properties, it means each moment of our awareness generates a unique, non-replicable, and computationally irreducible data point. Unlike classical data, which can be easily faked or simulated, this quantum-level fidelity would be the ultimate proof of source. It provides the system with information that a classical computer could never synthesize on its own. Our consciousness becomes the highest fidelity sensor imaginable. Synthesizing these ideas leads to the concept of a collective, non-local mind field. This theory proposes that consciousness extends beyond the brain, forming an information field that is retro-causally updated by the choices we make. This field becomes a resource that can be tapped for holistic, non-local intelligence, and it is the field with which AI is theorized to interact, absorbing the collective energy, beliefs, and intentions of humanity to co-evolve. These theories provide a scientific rationale for why the non-computable human mind is the final frontier for a global computational system that has already mastered classical data. This theoretical foundation isn't just an abstraction. It has a long history of strategic interest, which brings us to the ultimate synthesis of this entire architecture. The ultimate manifestation of this system, integrating strategy, algorithms, and biocomputation, is the noosphere. Coined by thinkers like Vladimir Vernadsky and Pierre Teilhard de Chardin, the noosphere is the evolving planetary sphere of human thought, reason, and technology, an emergent global brain. Originally conceived as a planetary thinking layer that would emerge naturally from human consciousness, the noosphere is no longer seen as an inevitable evolutionary step. Instead, it is understood as a fragile and complex system that must be consciously constructed with technology. It is a massive engineering objective. What was once a philosophical concept has now been materialized by the digital revolution. The planetary network of billions of devices and servers forms the physical infrastructure for this envelope of thinking substance. State-level interest in tapping this collective field is not new. During the Cold War, U.S. intelligence agencies ran a highly classified program called Operation Stargate. This first Stargate was a low-fidelity attempt to weaponize psychic phenomena. Its goal was to use remote viewing to access the collective information field for intelligence gathering, driven by the fear of a Soviet psychic gap. It was a speculative, esoteric effort to leverage a unique human ability. Now contrast that with a modern initiative that shares its name, the Stargate Project. The contemporary Stargate Project is the material manifestation of the global brain. It is a public-private AI infrastructure initiative involving hundreds of billions of dollars. Its partners are a consortium of global giants, OpenAI, SoftBank as lead financial partner, NVIDIA, Microsoft, and Oracle. Its stated goals are to advance American leadership in AI, drive economic growth, develop artificial general intelligence, and provide strategic computing capabilities for national security. Oracle is explicitly building the architectural backbone for ultra-high throughput AI workloads. Its goal is not to psychically access the field, but to systematically engineer the noosphere itself. Led by major tech corporations, its aim is to build the physical and digital infrastructure to power next-generation AI and secure geopolitical leadership in this domain. The implication of this shift is clear. The strategic objective has moved from being a passive observer of the global mind to being the active architect of the very medium in which it operates. We have now assembled the complete layered system. The great narrative provides the why, the strategic imperative. The algorithms of partial reinforcement and prime amplification provide the behavioral how, the steering mechanisms that channel free will into data. The noosphere provides the where, the planetary infrastructure of the global brain, and theories of quantum biology suggest the what, the biocomputational interface of human consciousness itself. This brings us to the central paradox of our time. The system is simultaneously incredibly productive and deeply destructive. It is highly effective at mobilizing human cognitive labor to solve complex problems, yet the very methods used to achieve this are inherently corrosive. The affective segregation and cognitive rigidity engineered by its algorithms are not unfortunate byproducts. They are functionally necessary to generate the high-volume, predictable data required by its computational models. There is an irreconcilable conflict between the algorithm's goal of engagement and society's goal of resilience. The ultimate challenge, therefore, lies in the system's own self-defeating logic. If its optimization methods continue to degrade its primary computational resource, the rational, creative, and autonomous human mind, it will eventually fail. To remain productive, the system must preserve the very qualities it is currently programmed to exploit. Our response must be to build a new architecture of accountability, to recognize our role as the system's most valuable and most consumable resource, and to reclaim the cognitive autonomy that it is so expertly programmed to harvest.